Hello, everybody. Good morning, good evening, good afternoon, and welcome to our latest edition of Neo4j Live. Today, the topic is going to be essential GraphRAG, and I'm super happy to have Tomaz Bratanic join me live on stage, basically virtually at least, on this episode. Hi, Tomaz. How are you doing?
Hello, I'm good.
Hello.
How about you?
Good to see you again. Good you're joining one more time of this series, and I guess congratulations on releasing the new book together with Oscar Hane.
Yeah, thank you very much. It was I will, as books goes, it always takes longer than you expect it to. But I'm happy we got together and made the book.
Yeah, super cool. And I think the book is going to be the topic for today. So before we dive into that, and if you don't know Tomaz, haven't heard about him, I'll let you introduce yourself in a little while, but Tomaz is a content powerhouse, I would say. I think you have written so many amazing and insightful blogs over the past couple of years, specifically around AI. I think that's your key domain. Lots of interesting insights, lots of hands-on tutorials. So there was a while, and as you know, I'm writing the Neo4j newsletter. There was a time when I actually had to search. Well, I cannot put another article from you in again this week. I need to find something else. But then they were so good, so I featured you lots. And then obviously now you were busy with the books. But I have linked your blog, your Medium blog, down in the video description on YouTube. So if people want to catch up and read some stuff from back then, you're welcome to do so. But yeah, you're amazing, Tomaz, and it's great to have you. But do you mind saying a few words about yourself?
Okay, so I've been working with Neo4j for feels like a long time, so it's like 8 years or something like that. And I've the previous book that I've written, it was kind of the focus for the first 5 years of my Neo4j journey, and it was graph algorithms. But then, like 2 something years ago, basically GPT 3.5, GPT 4 came out, and then that's when kind of the world changed. And I still remember I was kind of lucky. I got early access to GPT 4 quite early on. So I got to explore what it can do and what it can't do very early, and that's when kind of my learning in public started. Because like last year, probably for the whole year, what I was doing, I was basically contributing to frameworks like LangChain, Llama Index, others, and then writing about these new features that we've implemented. So it was like, for me, it was also very interesting because it was like I was working on LangChain, Llama Index, so like these very popular frameworks, and we've added the graph kind of modules. It was interesting to see some people are doing this, some people have slightly different ideas. There's like a lot of kind of parallels, right? And then, so we've seen kind of what people are using, what anecdotally works, and we decided basically it's time to write a book. And I learned I don't want to write it myself again because it takes too much time. So me and Oscar decided to join forces and then write the new book. So that's basically, and I feel like it's also really great timing because nowadays it's all about agents and like MCP servers and all of that. And no, that's really nice, but nobody is really talking about how to implement those tools, right? How to do. Basically, you just say you give the LLM a couple of tools, and it becomes this really powerful agent, right? But how do you actually go about implementing such tools and retrievers is, I think, where the magic happens, and not a lot of people talk about. And this book was kind of designed that that we would kind of go over different options for retrievers. So we kind of do like a gentle introduction, and we start with like basic RAG. So we just do simple vector search to kind of familiarize people with what's going on, what's the most basic thing, and then we go and show like how it can be customized and expanded, and then we throw some structured data in the mix, because my mission, basically for the last 2 years, was kind of everybody's talking. Now it's not such a big problem anymore, but like for the long time, everybody was talking like chat with your PDF, and like PDF is the only thing that can be retrieved, right? And I was like these big, enthusiast about structured data. So there's like a lot of structured data and value in having structured data in your knowledge graph. So basically, it allows you to kind of improve or add more functionalities to your chatbots, right, that aren't just available if you just do simple vector search, right, and so on. And I feel like my idea was, when I was writing a book, so basically everybody knows about chat with your PDF, and that's kind of the starting point. But now I want to take those people who've done like the basic RAG and walk them through, and like not so much to get them. The book is designed more to get people to think about different concepts, how to think about the data, what you're retrieving, what are the questions you want to be asking or answering, and it kind of gives you this like a journey to learning how to do a lot of things. Because like when you're talking about RAG applications, right, it's quite complex, because basically you can think about the whole like search space. So there's like on the one hand, you do what's your input data, right? Is it structured? Is it unstructured? And if it's unstructured, how you want to deal with that? Like, does your use case work just doing simple text embeddings, or do we maybe need to extract some information from those documents, right? Or maybe summarize it, and basically we walk through different types of data and what you can do with it in terms of chatbots and RAG retrieval. Because I feel like that's the most important thing, right? There's like 5,000 frameworks, and basically they all do more or less the same thing. And that's not really the fun part. The fun part is actually seeing the prompts, actually seeing the code, what's going on under the hood, so that you can kind of, because if you just do like similarity search with an LLM, I mean, like a lot of times when you're using frameworks, a lot of these prompts and code is abstracted away, so you don't really know what's going on behind the scenes. So it's really hard to kind of debug or improve, because it's a little bit as a black box. And our mission with Oscar was to kind of show you what's under the hood, so you know what's going on, and you can play around with it, customize it, and make it fit your problem.
Yeah, that's cool. You just mentioned something that kind of like was almost my first question is, you said, you start with similarity search. Oftentimes you start with vector search, and then you have this traditional approach that people are still using a lot. And your book is called Essential GraphRAG. So you take one step further into the graph direction, I would say, and give it a little bit more, like just outlined grounding or more context. Do you remember one moment when you yourself kind of like made that realization, think, okay, actually GraphRAG is just so much more powerful. It gives you so much more opportunities and so much more possibilities that then, it needs to take place. It needs to happen, basically, that you then said, okay, I want to know more about this. I want to approach this direction. I want to go into this direction. I then want to obviously write a book about it.
So for me, I think a lot about this conceptually. So for me, kind of an interesting realization was basically, you kind of have to take a look at like most of the time you're dealing with text embeddings, right, with chatbots. But it's very important for you to understand the limitations of embeddings, right? Because I see a lot of times what people do, they just kind of embed everything, even like tables or like records and whatever, and then just put it in vector index and hope that you will get good results, right? But for example, when you're asking questions like that require kind of more structured operations, which are kind of like sorting or aggregating, even filtering in some sense. Like if, for example, you want to say who has the highest salary in Neo4j, right? And basically what you have is you have records of users, let's say embedded, let's say all the property or employees, all text properties of an employee are embedded, and one of them is also salary, let's say. If you use text embeddings, you won't get accurate results, right? Because text embeddings work like a recommendation system. Okay, here's like some text that I have, and find me some semantically similar text. That's basically what it does. That's the function. It does it really well, but that's its function, right? It does not function for like sorting, right? Because that's more a structured operation. And for such, you need more structured data representations like a knowledge graph, right? And why I personally like knowledge graphs the most is because you can have both, the best of the both. You can have both the structured data and the unstructured together connected, right? And that opens up a lot of possibilities for various question answering techniques.
Yeah, I think that's very important to make that distinguish, or to make it very clear that it is not just PDFs or metadata or some unstructured data you put in into a knowledge graph, and then you analyze that and help out an LLM. You have structured data or as well, and you can use that as well, and you can combine the two, and that's, I think, is it's nice to analyze unstructured data. It's nice to do that, and to be able to finally make sense out of the data that previously wasn't quite as accessible. But it is, I think, the real power comes when you combine it with your existing data that is in a structured kind of format.
And I mean, with graphs, it's also, I mean, you can also extract structured information from PDF as well, right? Because in the book we have an example for legal, right? For legal contracts, that's a very kind of mainstream use case that we see. So basically, one thing in legal domain, it's kind of very it's very easy to find examples, right? So if you have like your internal contracts with, let's say, suppliers, and you would say like, how many suppliers do we have, right? For example, or like how many active contracts we have with our suppliers. When you're asking such a structured question that requires a little bit of filtering and aggregations, text embeddings fall completely off, right? So sometimes, because what I always want to say is that like GraphRAG isn't really competing with vector search. It's more like augmenting it, right? Because either you can just do like a hybrid search and combine base RAG and add GraphRAG, or basically, I mean, in the book you see a lot of a couple of examples, but for example, we also added Microsoft GraphRAG approach in the book, and in that case, it's very interesting, right? You have your initial documents, but then you process them, and instead of embedding text chunks like you would do in a base RAG, what you do, you embed the entities that you extracted from the documents. And for some reason, researchers have shown that that approach works very well. So instead of embedding original text, you embed extracted entities. And if a lot of information is this kind of entity-centric, right? So like, what do you know about Neo4j? Like, what was Alexander doing last summer, right? So it's entity-centric, and in that case, due to the pre-processing pipeline, you get also much better results, right? So basically what we haven't said yet, but basically GraphRAG, I feel it's like an umbrella term for anything so it's not just a single method that would be used, and it really depends on the types of data that you're dealing, right? So do you have documents? Do you have CRMs? Do you have Excels, right? How clean are they? and such, and also like the types of questions you want to ask. And how I see it, there's also always a little bit of reluctance when you start asking these types of questions, because a lot of times I've worked with people and you ask them like, so what's the scope of this chatbot? And it says basically anything, right? And it's like what they want is to work to do, and they say anything, right? And then you say, okay, how are we gonna evaluate anything? And so basically, you need to do a little bit of upfront work because, like with naive vector approach, you just select a chunking size basically, and then you embed everything, and that's about it.
Yep.
Whereas with GraphRAG, you kind of have to try to understand the data a little bit more, like how to extract values, right? And then you can there are different options, like whether you can use more generic retrievals, like text to Cypher or something like that. Or in some cases where you know exactly what you want, you can build like subject matter expert tools, like so that the database query created isn't created directly by an LLM, but by a subject matter expert, for example. Right? So it's like really hard to be. I mean, it's a very vast area, right? So there's like a lot of things one can do as a GraphRAG. It just depends what's basically your data and how clean it is. Right?
Yeah. I think you almost answered a question that came in through chat. So again, open invite everybody. If you watch this live at this point in time, please type in questions or comments that you have, and we can see if we can answer those. But Yuri asks, what do you use? Microsoft's GraphRAG and or Neo4j GraphRAG Python? Are there advantages? Are there differences? I think you just mentioned this a little bit. But
Microsoft GraphRAG and Neo4j GraphRAG are actually different. Microsoft GraphRAG implements the Microsoft GraphRAG approach, which I was mentioning, is also in the book. And the Microsoft GraphRAG approach is basically a very specific technique that you can basically do some entity level and community level summarizations of entities found in the documents. And so that's Microsoft GraphRAG. And Neo4j GraphRAG Python is a kind of Python library that implements many retrieval patterns, right? Because the Microsoft GraphRAG is just one very specific implementation where it also has a predefined graph schema. And Neo4j GraphRAG Python is designed more for, how I say, like model agnostic approach that works on any model. And because you don't know the graph schema in advance, you have to take more generic retrieval approaches, and that's what you'll find in Neo4j GraphRAG Python.
Yeah, cool. And if you then accept that, you take the schema, you take the structure, you do some definitions for entities and all of that stuff, and put that in your graph, you see a clear improvement, and in your point of view, that's the better way of working with a GraphRAG approach, or it depends?
I mean, like I said, almost always you will get accuracy improvements with GraphRAG because, like I said, you're not really competing with vector search. You can just take vector search and maybe expand what it is a little bit, or slightly tweak it. So I would basically expect, because like even if you, because when I'm talking about structured data, like even if you're still doing vector search only, you might still want to maybe extract some metadata so that you do metadata filtering with vector search, right? So basically any level of structured data that you can add around your documents will definitely increase the accuracy, because basically you're just kind of enriching your data model, right? So, and because you have more information available in your knowledge graph, you can do more accurate retrieval.
Yeah. Cool. They come in a couple of questions around the same, I would say, kind of topic. So let me try to summarize those. And I think it's a good fit to go on to this from what you just said. So, but you create a knowledge graph, you build that up, and then you have a couple of ways of how to do it. You define a schema, you do entity recognition, you use ontologies maybe as a structure to define that. And the question for all of these approaches is, do you have a recommendation how to best start, how to best build a knowledge graph, depending on the data you have, maybe a little bit, but also maybe on what is ideal constructing a knowledge graph for a GraphRAG application then in the end.
So what I do for people starting with GraphRAG is I always suggest people to start to play around with some structured data, right? Because most of the time, most likely you've just played with PDFs and RAG in your chatbots. So now we kind of have to start kind of make you think about other types of data, right? So, and one thing I will also mention is that like building graphs from documents can be challenging, right? It's not the easiest thing ever. So if you're new to GraphRAG, I would suggest start with some structured data that you already have, and it could be like, if you run a business, it could be like sales data or like CRM data, or maybe you can connect. What I like the most is this kind of digital twins, or like customers 360 use cases, where, for example, if you want to ask questions about your customers and sales, for example, you could combine your CRM, as I said, and maybe web store or sales data, revenue, whatever, and then maybe enrich it somehow. And because I feel like the magic of knowledge graphs happen when you combine multiple data sources, right? Because when you're dealing with just a single data source, yeah, but this you can say, okay, you could do this multiple different ways, right? But now, okay, now let's add 5 different data sources. Now it can get complicated, but with knowledge graphs, it's basically, knowledge graphs are kind of designed to take this complexity and make it simpler for you as a developer. So for me, the kind of use cases where you might fall in love with GraphRAG is first get some clean data, right? Because in real life, what you will do most of the time, I mean, it's the same thing as the data was before, right? If you have to clean your data, right? And that's kind of the most important thing, and that's been to do for the last 30 years or so, or even more, right? So, and then build a graph and start thinking about different kind of retrieval patterns operations, right? So am I looking for one specific thing? Am I looking for like an information that spans 5 different documents? Or maybe am I counting some things, like how many mentions of specific entity were in a document or something, and then think about basically how to implement retrievals that support all these types of retrieval operations. And that's kind of my, because like I said, this book, while it's got very specific examples, the idea is to kind of introduce these new concepts and get you thinking about on a more like conceptual level.
Yeah. And then is this maybe one of the misconceptions when you're talking with GraphRAG or working with GraphRAG, that you have? I think people played a lot with the PDFs or with some unstructured data, and then they think maybe just to apply the same principle to structured data, but then you have to actually take a step back a little bit, and I mean you should be doing the same probably with unstructured data as well, to give it more of a guide and define a little bit more of a schema, but you have a little bit of a different approach. You cannot just throw it in and hope for the best. You should think a little bit more.
Yeah, exactly.
Yeah.
And I mean, at the end of the book, we also have a chapter about evaluation, right? Because I feel like evaluation is about the most important thing of any GraphRAG project in general, because like you're dealing with LLMs and prompt engineering, and nobody really knows how LLMs will behave, right? It's very hard to predict if I add an exclamation point, at the end to tip it $100, will it change anything?
Yeah.
And I mean, you can kind of guesstimate, but you never really know, right? So you definitely need benchmarks, basically do evaluations. And I like basically benchmarks and evaluations for two reasons. One is kind of to track the accuracy of your applications, but the other is to define the scope. Because like I said, when you talk with customers or people, you say, so what do you want this chatbot to do? And they say everything, right? And I like the expression that I heard. I don't know from who, but I heard the expression like, we can do anything, but not everything, right? So
yeah.
I like that one. So basically,
that's good.
If we can define, and basically the evaluation data set forces us to define the types of questions we need to be able to answer. And also because it's always kind of the types of questions, but also how do you want to answer, because you have a lot of kind of these UX decisions that you will have to face, right? So for example, if you ask, let's say you have a movie knowledge graph and you ask like, give me all the movies that were made after 2000, let's say the year 2000, that's just too much movies to fit into the context. And it doesn't really make sense, even if you could fit, I don't know, 10,000 movies in the context of the LLM, right? It doesn't really make sense, right? So then how do you kind of handle these types of cases, like these UX decisions, right? And that's because you need also the ground truth, and it forces you to kind of walk through and define the scope of the applications, which also allows you to evaluate. And I feel like that's basically the most important part of the project. And like defining benchmarks, it's harder. I mean, probably not. People say it's boring, but it's also quite challenging because you have to kind of when you're building evaluation data sets, you're kind of designing the chatbot, right? How should the chatbot respond? Like, what's the user interaction? Right? So there's a lot of kind of details that go into constructing benchmarks.
Yeah. It's just to stay with the topic a little bit. What do you have any recommendations on benchmarking, evaluation, testing? I mean, is LLM as a judge something you would recommend doing?
I mean, it depends. It slightly depends on, but in like I say, 80% of the time, it's like LLM as a judge, and you want to kind of evaluate different parts of the retrieval pipeline, or like the RAG pipeline, right? Because like retrieving the data and then generating the final answer should be like evaluated independently, for example, right? Because sometimes the LLM could get correct kind of context, but it would interpret it invalidly, and even though the context was correct, the final answers was accurate. Or like sometimes with LLMs, we say, okay, the context didn't say anything, but now because I know this question, maybe you have like a more general data set, right? It will just kind of answer from its internal knowledge. So you have to kind of think about all these different types of edge cases that can happen. And I mean, when you go into benchmarks, you will start noticing these things. And for me, it was okay. Designing the benchmark data set is really labor intensive, even though it might not seem. But then running the benchmarks is the best thing ever, right? Because when you're doing some, let's say, prompt optimizations, you have no idea. Like if you don't have benchmarks, you have no idea. Did you actually optimize it, or did you make it worse, right? And okay, that's fine with demos, right? But like if people depend on these applications, and you introduce like some breaking change or something, and you have no idea about that, it can be stressful. So it's also, and like I said, once you have then the benchmark, they say you will run it all the time because it's like it gives you this feedback loop that you can learn from, right, and kind of assess what kind of works and what doesn't.
Yeah, cool. Before we switch topics a little bit and go into agentic GraphRAG, which I'd like to move to next. I'd like to, because another two people asked kind of like the same question in about the retrieval strategy. If you have any recommendations, if it doesn't make sense to combine multiple retrievers, is that a practice you would recommend? Is there a specific pipeline that you think is making most sense to do?
Yeah, I mean, I would say like the space is still not, it's not like a mature field, so we're still kind of experimenting. But what I've kind of seen is basically how I see the tools is basically I see them like on a spectrum from like very generic to very specific. And maybe if I show you an example, you will know what I'm talking about, and it will make it easier for you to understand. Just a second. Let me share my screen. The screen, this one. So can you see my screen?
Yeah.
Okay, so this is chapter 5. And basically, when I find some code. Okay, so basically, how is it? Most kind of definitions are an LLM becomes an agent when you give it tools, right? And you can give it a variety of tools. The LLM doesn't really need to know anything. It just needs to. It just needs to know the name of the function, the description, when to use it, and if there are any input attributes. So that's kind of how you define tool to an LLM so that it becomes an agent. But then what I was trying to say is you have the spectrum of like more generic tools that are also more brittle, less robust, and then more custom tools, and that's like domain custom or graph schema custom tools that are usually less flexible but more robust. And let me just tell you what I'm thinking about. So this is text to Cypher. So text to Cypher is basically when you ask an LLM to generate a Cypher statement. So Cypher is a graph database query that retrieves the information from Neo4j and returns the information back to the LLM to generate the answer, right? And with text to Cypher, this is a very generic approach because usually most of the time what you do like zero-shot generation. So basically you give the LLM the schema of the knowledge graph and say, this is how my graph looks like. Now please write a query that retrieves information that can answer this type of question. And that's kind of that's what you will see also in frameworks. because frameworks are designed basically to be generic, right? Otherwise, they wouldn't be frameworks. And then on the other side of the spectrum, we have like very specific tools that can incorporate some custom logic, right? And for example, here we implemented a very simple tool that finds movies by titles, and basically it just does a lowercase search for the titles using contains and returns the information. And as you can see, this is an example of a very custom tool, because basically the LLM doesn't really need to know it's dealing with a knowledge graph or Neo4j. It just needs to know that if it needs to find a movie with this title, it can use this function. And it doesn't actually need to know what's the Cypher query, right? And with such approach, you can encode kind of the business logic here, or you can have like subject matter experts define the queries. So then when this function is executed, you are 100% sure that this Cypher query was executed, and this means that you get a lot of consistency and robustness, right? But you sacrifice some flexibility because it does only one thing and it does it well. And on the other side, you have very generic text cipher that works with any graph schema. So how I would say is basically, if you're building, excuse me, GraphRAG pipelines, start with generic approaches, see what works, what doesn't, and then when you learn more about the data, maybe about the retrieval patterns that don't work just yet, then you can start thinking about adding custom tools. So let me take a sip.
Yeah.
You can think about adding custom tools, and these custom tools can be like vector search, keyword search. It can be like a lot of things, like dynamically generating Cypher statements and such. And basically, this is kind of the approach that I'm thinking about. But like, if I show you maybe the chapters, you'll see that basically these are the retrieval patterns that we go over, right? So like I said, we start with vector similarity search and keyword search. When you combine that, it becomes a hybrid search. Then we also show how to go beyond just naive text embedding strategies, how to improve maybe text embedding strategies, but maybe also how to improve prompting strategies, because you can rewrite the queries before running them through vector search, right, and such. So, like I said, it's still a very experimental space, right? Agents, especially, right? And that's why the idea was to make it more like longer lasting book, was to introduce you to these concepts, right, and not specific kind of frameworks or like quick implementations. It's more about getting you to think about data.
Yeah. Cool. And since you already have it open, the Agentic RAG window, I want to ask: is this how much has it changed in the last half a year or so with MCP? Is that has that changed the landscape for you dramatically, or has it just made things easier when you want to build an agentic driven GraphRAG system?
Yeah, sorry. I don't know what's it. So basically, MCPs are basically confirming what we kind of wanted to do for the last 1.5 years anyway, right? So it was kind of the general consensus that basically agents with tools are really powerful and they can handle a lot of things on their own, right? So if you give like an LLM like GPT-4 or like Gemini tools, it can do marvelous things. Like it can call multiple tools in sequence. It can do parallel tool calling. It can kind of resolve errors, right? And all of these things come out of the box with these powerful LLMs. Your only job is to implement tools that allow LLM to interact with external world, and in this case, it's a knowledge graph. So how do you allow the LLM to interact with your knowledge graph? And then we kind of talk about like the more complex the task an LLM has to solve, the less accurate the results will be, right? And if you kind of abstract the complexity away, like I showed with like custom tools, and so the LLM has a fairly simple task, then you'll get much better results, right? So basically, it just kind of validated it. The most like important thing is here we have I think there was a list of tools I want to show if I will find it. But basically in the okay, so this is what comes out. So we defined 4 tools for that agent, right?
Mm-hmm.
And now with MCPs, you could kind of define these tools once, and it could be reused by other agents, right? So the nice thing about MCP is that it introduces like a reusable standard. So like only one person has to build a very good text to Cypher MCP, and then everybody can use it, right? So basically, the MCP is bring the usability. But like I said, in frameworks and such, you will always find just like generic tools, generic solutions, because the guys building the frameworks don't know your domain, your data, and I feel like there's kind of this sweet spot right now for building Agentic RAG where you, if you know how to build these custom tools so that you can augment the LLMs, or basically your chatbots, I feel like you can bring a lot of value to your operations company and such.
Would you say that when you start with GraphRAG at the moment and you're just getting into it, you should conceptualize it directly for an agentic approach, or is that more of an optional thing still for you?
I feel like, I mean, what you will kind of realize that when you're learning GraphRAG, you're kind of learning different retrieval patterns, retrieval methods. And then when you want to add agents, you just pack different retrieval methods as tools, right? So you can first learn about text to Cypher, what it is. We have a chapter about text to Cypher, right? Generating query language from natural language. And you can learn about this retrieval pattern. You can see some prompts, maybe. I don't remember it exactly, but there should be some prompts. Yeah, so this is the prompt example. And now that you kind of, and like you can do like a workflow type. So you have a question, you generate a cipher, you return the results to the LLM, and then generate the answer. That's kind of the pre-agentic, where it's like a predetermined workflow. But like I said, you can take this retrieval method, package it as a tool, and expose it to the agent, right? So even though you might think you're not learning agentic stuff, you can still use it, right? Because like I said, it's all about the tools. How do you allow the LLM to interact with your knowledge base, knowledge graph?
Yeah. Okay. And then you can always enable or expand from your starting point and do more in that regard.
Yeah.
Now I'm just curious, and I see a lot of questions from users, so maybe we go into that. But have you seen recently any cool implementations where you are, or at least maybe also prototypes or something where you saw somebody do something with GraphRAG, maybe Agentic RAG, and you thought, okay, hey, this is a cool use case, maybe, because we always talk about, chatbots. That's still kind of like the go-to. But have you seen something that is like, okay, yeah, that is also possible?
I mean, yeah, I've seen, because LangChain also just did, they call it like ambient agents that kind of do offline tasks. But to be honest, what I'm more kind of enthusiastic about is now with the coming of the rise of MCP servers. People say that basically you can, that they added like 50 functions to an LLM, and the LLM like Claude or Gemini, and even when LLM was presented with 50 different types of functions, it still did like tool selections fairly accurately, right? So imagine the world of possibility you can allow the LLM to interact with if you give it 50 different types of functions. And then each function can have a couple of attributes, right?
Yeah.
So and it's not, I haven't seen a lot of exploration around this place, but I'm quite keen to do some experiments and see, because like I said, you can do more generic stuff that's more brittle, or you can go and try to do custom tools. And like custom tools, like, because they're less flexible, you need more of them. And then I want to kind of try to push the limit to see how far can we go, how many tasks can like a single LLM solve. I feel like it's quite because LLMs have become so very good that it's definitely worth experimenting.
Definitely. Yeah. Super. Before we go into Q&A, I obviously I wanted to ask you, or if I wanted to give you the opportunity, if there's anything else you wanted to mention about the book, anything, a key insight, maybe something why people should be reading the book, what's the top reason there, or anything else that we haven't touched in the conversation so far that you want to bring up?
I mean, I'll say one reason is it's for free.
Oh yeah, we didn't. True, actually, you're right. We didn't say that, but yes, yeah.
The book, if you go to neo4j.com books, right, essential GraphRAG, the book is actually available for free. You just need to share your email, and you'll get it on your email. And basically, you can read the book for free. And also, we didn't mention, but I also got, like, if you like reading and not PDFs, we also got you a 50% code, which Alexander can copy to the chat. So
yeah,
just today, the book was released on Manning, the printed version. And they gave me a 50% off for the book. So if you like printed books, you can get one for 50% off. And yeah, but like, as for like general why you should, is basically our approach is very, like I said, it's very conceptual. So it's very like database agnostic, domain agnostic, everything. So I feel like if you want to kind of expand your mind and go further beyond text embeddings, this is the book for you.
Cool. Yeah. Nice. I put the video, I put the links in the video description, both to the free ebook that's coming from the neo4j.com page, but also for the book from the Manning publication, where you can then use your 50% code and get the actual, the hard copy basically to read. So before we close, there were a couple of questions I wanted to go over. So Sachin asks if we have any recommendation for entity resolution, or for how get entity into the graph, and if sometimes connections or relationships, I guess, between certain entities are not quite mapped in the correct way. Is that something you think is okay, and still go ahead, or do you iron out all these crinkles and get it perfect? Is what's your approach?
So yeah, this is a very good answer or question, and I've been thinking about this lately a little bit, and basically, my kind of thinking is that you don't have to be perfect. You just need to improve upon the baseline, right? Because we kind of kick ourselves, but it's not perfect. There are like some discrepancies and so on and so forth. But in the end, it doesn't have to be perfect. You just take vector search, like if you're dealing with documents, and just try to improve it, right? And even if, I mean, what anecdotally I've been told a lot is that even with very simple methods like named entity extraction, or and then embedding entities as well as text chunks, you get a big increase in accuracy, right? So it's basically, you don't have to be perfect. You just need to improve the accuracy. Yeah, that's
Yeah, cool. Then another question from Ben. Ben asks, could you elaborate more on subject matter experts versus LLM implementations? Particularly, what do the non-LLM integrations with GraphRAG look like?
okay. I can show you, because I was just talking about this. Let me find. Okay, too many tabs. Share my screen. So this was basically what I was showing. So, for example, text to Cypher is a generic approach where the LLM generates the Cypher statement, right? So you don't really know in advance what type of query the LLM will produce given the time of day, because LLMs are non-deterministic, so you might get variation on the same type of question. Whereas if you build like a subject matter expert tool, it's like the subject matter expert who writes the query, and it can be static like this. It can be dynamically generated based upon the input parameters of the function. And basically, yeah, so in this case, it's the subject matter expert that builds the query. The LLM only populates some of the parameters, right? So the LLM in this case only needs to extract the title of the movie from the user question, and that's all it needs to do. It doesn't need to know that we're dealing with Neo4j. It doesn't need to generate a Cypher statement, nothing, right? So, and given that we've reduced the complexity of the task immensely, we'll get immensely more consistent results as well. So this is basically subject matter expert tools.
Cool. And there is another question here from BuddyList, which I think is going into the same direction a little bit. Are there any retrieval solutions that fall somewhere in between the generic text to Cypher and the super specific subject matter expert solutions? And then maybe let me add, is chaining together via maybe MCP an option to get there, starting with a generic text to Cypher and then
Yeah.
adding.
I mean, you thinking is spot on. It's just that you start with a static or like predetermined query, and then you would chain like something that allows custom transformations. And I've worked on a project that does this. We have like subject matter expert tools to pull data from Neo4j, but then we chained Python sandbox, because LLMs are quite efficient with Python, and they can use Python sandbox to transform, filter, or visualize the data, right? So that's like a really powerful approach. I feel like the MCP doesn't support that just yet, because nowadays when you're using tools, everything has to go to an LLM. I mean, you can implement it still, but it's a little bit more work. It's a little bit of hacking. But once we will be able to chain tools without an LLM in the middle, right? So because the problem is when you have a lot of data, you don't want to have the LLM evaluate it. You just want to kind of push them to Python and do visualizations, whatever. And I've seen more people talk about it, so hopefully probably we'll have such chaining capabilities soon, and that's really powerful. And that's kind of my way of kind of being in the middle of the spectrum. So you do the retrieval very customized, but then you allow because the problems we said, which with, let's say, aggregations, there are so many variations of it. It's very hard to kind of build a template for all the aggregations possible. And in that case, you kind of want to offload this complexity to an LLM. But yeah, that's definitely chaining tools is gonna be big, I'm thinking.
Cool. Very nice. And then final question comes from Matt. And Matt asks, do you use the LLM to clean your data, or do you do it manually? I think that goes back to when we talked a little bit earlier about when you ingest some data, when you try to either structured or unstructured data, and you have a little bit of a mess at hand. Can LLM help?
Yeah, so most of the time what happens, you kind of want to do a little bit of manual, but it's not really data cleaning. It's more like data definition or data modeling. Kind of this kind of manual, what you actually want to do, what should the extracted information look like. And then the actual extraction and cleaning is mostly tried to be offloaded to LLMs, because nobody wants to manually clean anything.
Yeah. That makes a lot of sense. All right, we're at the end of the session today. Thank you very much, Tomaz, again for spending the time today, for answering the question. Thank you for everybody for watching today and for sticking with us. I think I hope you all feel like Yuri does, and Yuri, because I'm reading this out now. Yuri, he just posted, the content is a holy grail of any RAG. So I think that's really, really nice. I hope everybody else found this session to be a holy grail of information. I surely think it was. If you want to continue, getting more out of that holy grail, read the book. Like we said, it's free as an ebook. It's 50% off right now with the code that I put in the YouTube video description through Manning. So if you want to buy that, do it there and save 50%. But if you're happy with the ebook, you can download it through the Neo4j website. Thank you very much, Tomaz, for today and for writing this book.
Thanks for having me. Always a fun time.
Yeah, no, obviously, anytime. I'm looking forward to your next blog post that I then can feature on the Neo4j newsletter. Might be chaining agents.
Maybe. Okay.
If you want to stick around and watch more, then I'll be back next Tuesday, I think it is, 30th of July. No, that's not a Tuesday. What is that? That is the Wednesday. Next Wednesday, 30th of July, we have Niels as a guest, and we'll talk about the new dashboards on Aura feature that has been launched a couple of, I think 2 months ago, maybe. And we will look into that, how that works, and how you can create nice dashboards in Aura directly out of the dashboard from there. Notes, I like to feature this because even the call for papers has been closed, you can already get in line and register for the date. So if you want to keep informed what happens, we will be running a couple of Road to Notes workshops in September. So if you have any any interest in learning more in GraphRAG, I'm very sure will be part of this, then register already. The themes for the day will be lots of AI things, but also basic Neo4j stuff around visualization, data analytics, and graph building. So join this. And yeah, with that, I think I'll let you go. Thank you very much for joining. If you want to know more, besides the book, we have a full GraphRAG learning course on the Graph Academy. Check that out. I'll put that in the video description as well. So you can learn with some hands-on sessions. But yeah, with that, I think we're done. Thank you very much, everybody, for watching. Thank you again, Tomaz, for today, and specifically, obviously, about the book for writing that. And yeah, see you all soon, then on live stream or somewhere else in an event or online. Take care and have a good rest of your day.
Bye-bye.
Bye.